Okay, I think we are ready to go, Professor Bishakh. You'll be sharing the screen. Professor
Yeah.
Okay.
How to share the screen? Okay. Oh yeah. Is my screen visible to you?
Yes, we can see your screen, but I think you need to put it on the slideshow.
Yes, that's what. It's taking a bit of time. Please check and confirm if it is available.
Yeah, it's clear.
Great. So, can I start?
Yes.
Okay, so I'd like to thank the symposium organizer on energy assist integrity management to give us a chance to share our experience on the application of intelligent pipe health monitoring robots for fuel transportation systems. This particular system has been developed in collaboration with GAIL India Limited and the Ministry of Education, and it was supported by the Uchatar Avishkar Yojana, that is Advanced Discovery Program of the Government of India. So I would like to share with you a bit of details of this particular system. Now, we know that pipelines are the key components to transfer fluids such as oil and gas over long distances. In India, at the end of 2021, there was over 13,840 kilometers of natural gas pipelines. And this number is 28,000 kilometers by the end of 2030. So that is the level of expansion that we are thinking of. Now, pipeline failure and rupture can be seriously catastrophic and may result in significant economic loss. For example, total of 1959 accidents reported worldwide between 2010 to 2018, causing 359 fatalities and incurred a cost of almost $518 million. So one can understand the importance of the management of such a system. Now, these are some of the kind of cracks that can happen in a pipe. So there are a whole range of it. Just a few of them I have shown you here. And what is the existing solution for it? Existing solution is the application of pipeline inspection gauges. So something like this. These are called pigs. And however, these pigs work on a blocked flow condition. So which has two disadvantages. It disturbs the flow supply and it causes a continuous chatter vibration that further affects the health of the pipeline. So this is one of these blocked flow systems. And thirdly, extensive pipe investigation deployed by international companies actually cause a huge revenue loss at the rate of something like $100 per kilometer of pipe length as per our investigation. So from all this point of view, it makes sense to develop a robotic system, and that's what we have done at IIT Kanpur. So this is the robotic system that can go inside the pipe without blocking the pipe completely. So we call it Pipeline Health Monitoring Robot, or PHMR. The specifications are 4 kg weight, overall 1.25 meter length, and the wheels are made of aluminum, body is made of aerospace grade aluminum, and there is a battery for the sensors and actuators and the microcontroller. Now, the entire system has a deflection here. That's most important. That converts the kinetic energy of the gas into the motion of the robot. So that is why the deflector is a very special shape. We have designed it based on the airflow analysis, and also there are bypass vanes there so that the speed can be controlled in such a system. Next is, of course, the speed control system. This is also one of our unique contribution in our patent design, which is based on a governing mechanism, and that can actually create a hydraulic control on the system. It is, the good part is it is passive in nature. Then we have optical sensing system, actually corrosion sensitive. So if there are corrosions in the pipeline, and one can actually keep these type of specifically for a particular type of corrosion. Then we have the touch sense. This is required in order to know that if there are cracks or if there are certain metal loss or if there is a metal deposition that's happening, both positive and negative, the touch sensor brings it out. So that is the touch sensor, where there are bimorph sensors which picks up the deformations of the system. Next, there is the flux sensor, which is very additional. We know about such sensors in things also. In this case, we have kept it for our validations and data verification, and also sensor data fusion. So this standard, and of course, there is a shock absorber, because the entire system moves at a speed of 20 to 80 km per hour. So that's the entire system that we have developed. Along with, so this is this system moving items monitoring robot in the pipe veins, different types of pipe veins, as you can see here. So these are from the PFD analysis work page. Both 2D and 3D PFD analysis we have carried out in order to understand what is the drag working on the robot and what is the velocity that is achieved. We have to develop a sensory integration system for all sensors, that is, there are 3 of these sensors for the crack and corrosion detection, and also rotary encoder, which keeps track of the movement of the robot inside the pipe. And then these signal conditioning, data acquisition part, and finally there is the RF transfer which sends the data wirelessly to the cloud so that one can actually see it. For in any computer with GUI, one can see that how the robot is moving and what are the important changes that the robot is doing. This whole thing is something like this. As you can see here, that how the system will be moving. We have developed a pipeline network, by the way. I'm going to show it to you in the next slide, and we welcome any other who would like to test their pipeline monitoring robot in our system. So so we can monitor. So this is the velocity tracker that we have developed, where we can monitor movement of this particular robot. Now this is the pipeline setup, baked and compressed that we have developed. It's a full setup. It's about 75 meters in length, and it has all the possible types of data that are generally faced in such a system. So some of the sensor data I'm just sharing with you that how it looks like. So this is, for example, sensor data that is coming out as this system is moving. So you get actually NFL data, magnetic flux data in this particular case. Similarly, you get, so there are these 4 MFL data that you are getting here. And similarly, you get the optical sensing and the touch sensing data. Now, I would just like to say that from the market access and the research impact point of view that there is a requirement of government regulations for safety and monitoring, which is very important at this moment. However, in terms of the development of such a system, monitoring the fastest way in Asia Pacific with a CAGR of more than 7%. So the market is growing very fast. Will be growing in edge. I think this for the oil and gas industry growth very much. So this is kind of a bull market assessment from our perspective. And as I told you earlier, that the usual cost is about dollar per kilometer, which costs for a 100-kilometer pipeline digging about $10,000, whereas the system that is developed here is currently it cost about 6,845, but for this is for the prototype. But however, for a full-fledged system which is mass manufactured, it will come down to about $2,000. So this we believe it will become very cost-effective way of actually going monitoring the gas pipeline. There are some of our works that are available in open literature, so you can easily go through. And also we have patents in this direction. So currently, somewhere at TRL 7 level, we are waiting for certification. There needs to be a certificate agency before installing pipeline and commercialization. That is the level at which we are. Yeah. I'm just showing a very small video. You can see the robot here. You can see the purpose here, and this is the internal picture here. And the robot successfully passed the gate, takes receipt of the part, and gives us the data. So the way forward for us is that we would like to take it beyond TRL 9 level we reach, and also we'd like to extend it for thermal and nuclear power plants, offshore operations, transoceanic pipeline, transportation from the mines, and micro robotic applications. So there are quite a few things in which we can extend. Thank you very much.
Thank you, Professor Bishakh, for the excellent demonstration of the pipeline crawler robot. Let me check with the organizers how much time do we have for discussion, questions. 10 minutes? Okay. We have about 10 minutes for questions. Professor Bishakh, I think we would like you to stay online for the questions. So as the questions come, we will just take them.
Okay.
All the speakers, they will.
What is the limitation of this system? My name is Piyush Arya. I am General Manager Mechanical at ONGC Hazira plant. My question is that what are the limitations of this robotic system for inspection?
Yeah. What are the limitations of the robotic system, right? That's what you are telling?
Yes, sir.
Yeah, there are several limitations at this moment. Number one is that the wireless communication system that works above the ground beautifully, but under the ground there are problems because it is difficult to get the signals out. We are thinking of several ways of doing it, but that is one limitation. The second limitation is, of course, the sort of robustness of the system, because we have these touch probe sensors, and which needs to be changed in every 200 kilometers. So it has a life of 200 kilometer range, and so we are thinking of how to extend it beyond 200 kilometer range. So that is the second limitation of the touch probe system. The other point is we have developed the speed controller, the passive speed controller, but the pipeline network that we have is only about 70 meters. So within these, it is difficult to check the efficacy of the entire system, because this speed controller, you can tune it so that this entire robot can move at a uniform speed. So that would need a larger pipe, line to actually see the efficacy of the system. I think these are the major limitations at this moment, which needs to be improved. And of course, the other point that I told you, that it needs to be certified. At this moment, we do not have such national certification process. Internationally it may exist, but nationally such certification process needs to be developed by the community.
Sir, one more question, sir.
Thank you, sir.
Sir, one more thing, sir. Whether it can be used for any pipeline which doesn't have any kind of flow. I mean to say, any pipeline without flow, can it be a crawling robot with a battery operated, something like that? Can it be used in that mesh?
Yes, that's very simple. We already actually initially worked on battery operated system, so that can be added and the deflator has to be taken out. It can work in a pipeline which does not have any.
Thank you, sir.
I'd like to know what is the max limitations on the diameter.
Oh, yeah, that's a very good question. Right now, it works on 8-inch diameter pipeline plus minus 10%. Okay, but one can scale it up or down.
You can answer questions or the previous speakers.
Yeah,
also.
somebody had a question for Dr. David Blum, and people can repeat. This is a session for everybody. Yeah.
Actually, he explained nicely on fitness for service and remaining life assessment, sort of, Mr. Shivakumar. My simple question, one question is what I have seen in the photograph, as you have explained, those are all component which has been taken out of service and remaining life assessments you have done, fitness for service you have done. But how about in-service vessels? And how would the accuracy you have? Okay, you have adequate competence on in-service vessels also, especially with respect to carbon half moly. Sort of a, see, the Tesoro, Dr. Manoj has shown that Tesoro refinery failure data. Even only after that, only that Nelson curve has been modified. I think, if I am not wrong. So thereafter, so what about the carbon half moly vessels? You can answer me later while consultation outside also.
I have a
I have a question to Mr. David of Shell. I just wanted to know, whatever the 3D scanning model you are taking using the cloud, point cloud data, how frequently you develop it to know the current state?
Yeah, that's a very good question. Thank you for the question. So we divide the multiple frequencies. So that's, for example, if you do laser scanning with terrestrial laser scanners, you place them on specific location, then you create a model. That's very time consuming. So that's, let's say, every 5 to 6 years. What we do with Air Compare is we do repeatable drone flights. So that is fully automated. It's called a drone in a box solution. So you literally take a box with a drone in it, put it on a location close to the asset, let it fly its trajectory, then it flies back to the box, uploads data to the cloud, and then in the cloud we process it into a point cloud. Let me repeat the question for those who cannot hear it. So I think the difficulty is in, for example, if you want to inspect the pipe racks, you cannot automatically fly a drone into these pipe racks. So that's indeed is a challenge. So with the drone you can fly on top of the pipe racks to scan them. That's automated. We have specialized drones which can fly within the pipe racks. So these are cage drones which have LiDAR systems on it, thermographic imaging and RGB images or RGB cameras, which we fly directly into the pipe racks, but that's, let's say, still requires a pilot to fly the drone because you cannot, let's say, due to safety regulation, you cannot do that automatically. Then the frequency becomes much less. Yeah.
My question is this in continuation to that. See, cage drone nowadays is new, every industry is developing. Now, after taking the images, drone images, you will be putting it in augmented reality to get the actual exact positions of the or deteriorations. Is it in that sort? Because I couldn't understand fully what you said.
Yeah, so a point cloud is a 3D representation of the asset. So what we do is we take the images, we use photogrammic algorithms to combine these images together and then convert that into a 3D model or a point cloud. And that 3D model you can see as a digital twin, as an augmented reality. You can look at it through your with a standard desktop system, but you can also walk into it with like a HoloLens that Microsoft is developing. And then within that 3D model, you see where the corrosion is, where the damaged insulation is. Yeah. So.
I have a question for Dr. Raghu Prakash. Sir, you said miniature sample, like this is essentially a thin film sample. Can it be subjected to high temperature test, like high temperature tensile stress or stress rupture test?
When I say the miniature, the thickness is one of the important parameters. We are sticking to about 0.3 to 0.5 millimeters. One of the reason is that we want to have it some multi-scale times of the grain size. Okay, so now there are people who are working in the research community who want to have a small induction heating of the samples, and then you want to estimate the properties. So I think it's possible to evaluate the properties at the high temperature too.
Is it in a developing stage or already?
Yeah, it's in the development stage. We have a community which is small specimen test technique community, and in fact it's mostly dominated right now by the Europeans, and we have the 6th international conference that will be held in September, and I represent the Indian interest, and then I'll be there.
Yeah, some positive movement will be very helpful for.
Sure. Yeah. In fact, I'm looking at it a little bit more than that. Where you could also look at creep plus fatigue. Yeah. Right. So impression creep is what is normally used for finding out the creep properties, but then impression creep coupled with the small punch testing, cyclic small punch testing, will give us the answers for both. So,
sir, one more question. This miniature specimen sample. So we have a lot of carbon moly reactors. So can these, scoop samples can be used to, get temper embrittlement, the ductile to brittle transition temperature, whether it has changed over time? Can it be used to, find out the temperature?
Yeah, I think DBTT has been used in general to identify what is the degradation in the properties. One way is to look at through DBTT. The other one is to look at through the the loss of ductility through a tensile test, standard tensile test, because it represents a simple test technology, and this is what normally people use. And in fact, with reference to the previous question on how to correct the temperature data, temperature effect on the fatigue data, generally what people do is take the ratio of your strength or the ductility at different temperatures and use that as a correction factor for your fatigue life. It doesn't work in practice because fatigue life is a power law relationship. So that's the reason why I push myself more into the fatigue aspects of investigation.
Thank you. So one more question to Mr. Shivakumar. In that vertical heat exchanger, in the vertical heat exchanger where there was a metal loss, so you had recommended for some weld buildup or whatever recommended wherever the metal loss is there. So what was the criteria used? Was it there was a stress less than allowable stress, or 70% of the allowables, or 50%? What was the criteria used for repair?
So from the simulation, with the criteria used for ASME section 8 division 2, there will be they have a load cases and load combination. As per the criteria, the membrane stress is 1.5 times 1.5 times of the allowable at the material temperature. That is one thing. Where you commit the bending plus membrane plus bending structure stresses, that will be a 3 times when effect of temperature. Based on these criteria, we have compared the stress with respect to the allowable. Then we have recommended for the further repair.
need a reference baseline survey also?
Yes, so the question is, do you need a baseline reference? So if you want to know how the site changes over time, then definitely you need to start with the baseline. But then just to find new anomalies or to do like a new scan of an area, then there's no need to have a baseline ready. You can still create a 3D reconstruction. You can still detect where there is corrosion, where there is damaged insulation. But if you want to start modeling how does the site change over time, then definitely you need to have a baseline. Yeah.
Hello. Yeah. Hi, David. Nitish here from GE. So actually we are also working on same type of solution. So I have one question. Like in plants, like we have a timer to see the time, for example. They are not digital. So are you capturing the pictures of that also? And if you are doing, how you are doing that thing?
Yeah, very good question. So I think what you're describing is another machine vision project within Shell. So there we use robots which make their rounds on a, let's say, daily basis. And then also take pictures, for example, of meters, of clocks, or other types of equipment, and then convert that to a digital signal. So that's indeed being done. We're using machine vision to analyze the image and then predict what's the value of the meter, what's the value of a, let's say, a clock or a digital text. Yeah, so that's done on a regular basis.
That's you are doing, huh? Okay, thank you very much.
Yeah.
Sir, I have a question, please. David, sir, that in a pipe rack, pipes are in a very proximity zone, that they're very nearby. So how do you, how this corrosion monitoring is done through drones?
So your question is how do we actually monitor the corrosion with drones?
Yes, in the pipe racks.
In the pipe racks.
Yeah. Yes.
Yeah, so the drones are limited by safety regulation. So if you fly them on top of the pipe rack, then you need to use very high resolution cameras just to capture the detail of the corrosion. So we have designed, let's say, or computed what are, let's say, the ideal lenses to use, such that you can still see the corrosion very clearly. If you want to detect damages within the pipe racks, where you have like multiple layers of piping, then it becomes more difficult. So in that specific case, we fly drones within the pipe racks, which are cage drones. So they are sensing their environment. So if they cannot fly against the equipment, they will just stop, such that it's safe to operate them. Other solutions are like a pole cam system. So what's a pole cam system? It's like a very long pole, and it has an array of cameras mounted on top of the pole, and you can simply lift it up into the pipe racks and then take images very close by. So that's still like time-consuming process, but the advantage is that you take pictures within the pipe rack, which you otherwise simply miss if you're doing human inspections.
So in that case, there is no thickness reading is being taken?
No. It's really it's only external visual inspection. If you want to measure the wall thickness, then you still need to do NDT measurements. Yeah. So we do model, let's say, surface areas. So what's the size of the corrosion visually from the images, and what's the increase over time and severity. So make a distinction between different types of severities like light, medium, heavy corrosion. But if you really want to know what's for example, if you have pitting or internal, external corrosion, and want to know what's the wall thickness reduction, then you need to have another type of sensor, definitely.
Then how do you do that thickness measurement?
Okay, we can discuss probably the details later. I think one last question we'll take and we'll wind up.
Thank you. No, my question was in the similar line. Partly you answered it, but see, for asset management, the entire damage mechanisms needs to be taken into consideration. Suppose if you look only visual examination, then what is the guarantee of integrity of the pipeline? Because these are the systems which are not only operating on one damage mechanism.
Yeah, that's a very good comment. I think so. This does not aim to replace all the different types of inspection mechanisms. So it's only trying to automate the external visual inspection, like people walking on field.
I think like this is a beginning of the digital twin. I understand. It's just a beginning, but it doesn't replace the shutdowns and the inspection methodology.
Yeah.
Yeah. Thank you.
Thank you. Thank you everyone for engaging and fruitful discussions. And once again, I take the opportunity to thank all the speakers and presenters in this session. So I'm sure there will be, all of them will be around here today and also most of tomorrow. So we can still continue the discussions during breaks and lunches. So keep this going. So any instructions?
Yeah, so thank you all for attending. So I would like to thank the speakers for the excellent presentation on various aspects of asset integrity. Special thanks to Dr. Manoj for the smooth conduction of this session. I hope you have enjoyed this session. And with